Here we have a Nintendo Switch OLED that was mailed to us because it doesn't charge. The customer included a note. Says, I received this Switch OLED as a gift and it did not charge. I was able to get it to charge one time, but it started smoking and it never charged again and has no power draw. Let's take a look. The first thing we're looking at with a visual inspection is the USB port itself. It clearly looks damaged. Now, it might just be the USB port, but the truth is, when you have a damaged USB port and you apply power to it, you run the risk of burning out chips on the motherboard. And that does track with the fact that the customer said they said it started smoking. So I would assume that a chip burnt out, but we won't know until we get on the inside. I'm going to open the system up and get the board out. We'll be right back. Upon opening it up, I can see that this tape here has been removed. That at least indicates that someone's opening it up to a degree, which means that this might have prior repair attempt. Before replacing the USB port, we're going to do a board inspection. First thing I'm going to check is the fuse right behind the USB port. It does have continuity. And let's check. I'm in diode mode. I'm going to check some of these capacitors by the BQ. I do have a normal reading there. Everything looks good. Wait. Okay, that one's backwards from a normal switch. I forget sometimes. Let's check here. Good. Good. Come over to the M92. And the first three I'm checking is right here. 0.35 is good. 0.52 is good. 0.35. You know what? Everything seems okay right here. I think this one's reading 0.168, and that does seem low, I think. I'm not actually sure. I'm going to grab a donor board and check. On my donor board, it measures 0.28. So I'm thinking 0.16 is low. That's not a good sign. Let's come over to the PI3 and check a couple things. Yeah, that's shorted right there. Guess I should move this into the camera. This guy is short to ground, and that's going to be a problem. So I don't see any burn marks. I'm trying to figure out what would have started smoking. Let's check this guy right here. That filter's good. Let's check this one. That one's good too. Now, the bad news is that if this capacitor is short, that could be a problem with the eMMC. And we won't know until we take this chip off and see if that short resolves, because it's possible that this chip is causing the problem right here and with the capacitor on over by the M92, this guy here. Of course, this one's not dead short, so I feel like that gives me hope. But let's do this. Let's take this PI3 chip off and the USB port off. No, let's take the USB port off first, and we'll rule out that there's a short coming from the USB port. Now, I could just take it off and start measurements, but the method which I do USB port replacements is putting another one on the moment I pull one off. So I'm not gonna only take it off. I want to put a replacement on. And if that doesn't cure the problem, then so be it. I'll lose a $2 part. But I mean, the overall goal here is going to be a repair. So why not put it on anyway? Let's start by putting some flux here. And I don't have the tweezers I prefer. Why am I always losing those tweezers? Oh, look at that burn. That's where the burn came from. How about that? Okay, now I need to slow down. I'm not putting a port on right now. That's bad news. Okay. Let's take a look at how bad this is. Maybe if we're lucky, this char is not very deep and it's not going to burn, bridge anything. Because the char is conductive. That's what makes this a big problem here. Just trying to clean this off. It's on there pretty good. Boy, oh boy, oh boy. You hope for a simple repair, they turn out complicated. Okay, so it's just one pin that's blown out. One pad. The problem is going to be that char. I'm going to try and clean this up a little bit, and I just keep getting more and more char. Look at that burnout right there. That's crazy. All right. What are we going to do? Let's see if there's any bridging happening between these pads. So, we have no continuity there, none there, none there. That's a good indicator that this isn't going to be a problem. So, let's put a little bit of, I don't think regular green mask is going to stick to that, so I'm going to use some UV glue. I'm going to try and very carefully place some right there. Now, I don't really want it on the adjoining pads, but I may have to just scrape it off. I'm going to use my UV light to cure that real quick. And that's going to prevent that char from touching anything else. I'm going to use my grinding pen. We sell this on our website, dvdgameexchange.com. I just want to make sure there's not glue on this adjoining pad. All right. Now, I want to retin these pads before installing the new port. Put some flux on here. And some fresh leaded solder. I don't need to remove the old solder. Some people will say you do need to. I don't. Yeah, I didn't quite get through that glue. See, and that's going to be a problem with getting the USB port to stick. So I'm going to have to grind through that one a little bit more. Let's get that off of there. So that we can retin it. We'll just go to 10 on this one too. And we'll clean that off. Now, are we going to be able to tin that pad? Hopefully. What on earth is going on here? Why can I not tin that pad? That one's working good. I'm sure I would have scraped off enough of that by now. Alright, I ground that down to the copper, so I don't get it to stick this time. I don't know what's going on. There we go. Okay. Guess I wiped away all my flux. Come on, baby. Now, we still need a wire right there in order for the USB port to make a proper connection. Now, let's try and connect a wire here. I want it to connect right there. You know, I think I want to run it all the way up. I'm holding this way too far back on the wire. Good. Nope, not good. Dude, doing jumper wires on Nintendo Switch ports is just the worst. I lost it. Damn it. I think I'm just going to connect it right there. I don't mind doing jumper wires on HDMI ports where you're just connecting things. These rebuilding pad type of jumper wires, they're just the worst. Okay. Now I'm going to cut that right there. I need to clean this up a little. Now, I don't normally feel like it's necessary to pre-tin a USB port, but I want to give this the best chance I can of sticking to the pads on the first go. So we are going to pre-tin the pins on this USB port. I want them to all just be ready to attach and not let go. So those are pre-tinned. Let's try and place this port. I should have had the holes cleared so I could just put pressure on the port before trying to place the USB port, but that's okay. Add some flux right there. I'm going to hold some pressure as I remove the heat. Wait for that solder to harden all the way. Then I'm going to come through and redo the front legs. So let's get these guys here. If I didn't do it good, I'm going to have to redo it. And I should have had the holes cleared. I don't know why I didn't think of that. So that I could place the port right on top of the work and hold pressure before applying heat. Now there was the one that I jumped the wire onto. It's holding pretty good. I'm going to use my USB port testing tool and see what the results are. Not even freaking close is what I think. Hot dang. Ah, okay. That is not making proper connection at all. Okay, here we go. I pulled the port off and my wire stayed in place, so that tells me the wire was put down pretty good. Now I got the holes cleared so I can put this where I want it, and I'm going to heat from on top. Let's go ahead and add a little bit of flux here. Oh yeah. Okay. Now I am going to heat on top, holding pressure down on this USB port. Right where I want it. Right there. I also pre-tin this port, so as I get the board to melting temp, it should be making a good connection with all the pads. And I'm just going to hold the heat there a little bit longer just to be sure. That seems pretty good. Now I'm going to hold it until I'm certain that the solder has cooled down enough to harden and attach. I could see that it's hardened, but I'm going to continue holding. I don't want any weak joints there. Now the one that the wire is on, which is the one that's on the right side of this fuse, right here, I'm going to put a little bit more solder there with the soldering iron, just to make sure that it's attached. And I'm going to use, I think I'm going to use my finest point tip. Nope, because I lost it. Well, that's great. It's fine. I'll just use the one that's on there. Make sure that that attaches good right there. Should I put a little bit of solder on? Yes, I should. Now I want to know that that is touching, so I'm going to take a meter right there. Okay. These two are on the same line and they're touching. There we go. Okay. That's attached. Let's see what the USB port tester says. Now the thing is, I didn't use the USB port tester before doing it because the port was damaged, and when a port is damaged, I don't stick anything in there. I don't stick a charger in there, I don't stick a port charger in there. I don't want to damage my tools, and I know it's not going to work anyway when it's damaged, so anyway, let's take a reading here. All right. So pin 20 is not showing as good. That's that 0.16. See, that's what makes me think I was getting 0.16 on that one capacitor. This actually makes me think that the USB port is installed good. So I'm going to finish installing it here by flowing in some solder so that I don't accidentally bump this thing out of the way. That way the port will hold nice and strong. For the rear ones, I like to use a larger iron when I'm doing it this way, because the board wicks away more heat in the back there. So I'm just going to hold that there, heating up the board and the port until I can get the solder to flow in. Okay, good. We'll do the other side as well. See how I'm heating the board and the port, and I'm putting the solder in right there, because it's not going to flow in right there unless the board and the port is hot enough to let it flow in. That's how you actually get it to flow in and not just put solder on it, you know? We're just going to turn our attention back over to these chips. Now, this short is gone. I'm getting 0.36 there, and that's good. That means the eMMC is safe, and actually this chip is good, and that was in fact being shorted out by the USB port. This reading, however, remains at 0.16. I could get my probe on there. And that's the reading on pin 20 that we were getting on the port tester. I know the pin 20 on the port tester goes to this chip. And so I'm thinking this chip got cooked from the bad USB port. So we're going to replace it. Get this solder to melt. There we go. All right, before I put a replacement on, I'm going to test that cap and see if the short is gone. The cap is still reading low, and I guess I don't actually know if it needs the chip on there in order to read correctly. So I'm going to prepare to put a new chip on by tinning these pads with leaded and put a chip on and see what happens. Okay. I don't want to overblast this chip with heat, so I'm going to heat up the area until everything becomes melted and then place the chip in. I think that looks aligned okay. Might be a little low. I can't tell if it's low or if my microscope is crooked. Okay, with the chip on and it's aligned properly, I promise you my microscope is crooked. That's still reading 0.15, but let's check the port tester. Okay, that comes up all green. If I could get it to focus. Camera wants to focus on my face. It's interesting anyway that I questioned that 0.16 reading right there, and I had a 0.16 reading on pin 20, but now that pin 20 is showing 0.52, I guess it's not related to that cap, and that cap remains 0.16, which might be normal. I have good USB port readings. I have a strong indicator right now that this is going to work. I just did a dry bench test with the battery and a charger with a meter on it. And although my USB port seemed like it might have some flux in there, it's working. So I'm going to put this back in its housing and see if we get this thing to turn on. All right, at the moment I have it plugged in. There's a charge symbol on the screen. That's a good sign. Once it turns on, I'll show you that it worked, and then we'll wrap up the video. Right now you got to wonder, is it working? I think it's working. And we do this repair, we do mail-in repair, so if you want to arrange repair with us, you go to dvdgameexchange.com. You can arrange mail-in repair with us. We fix Xboxes, PlayStations, Nintendo Switch. Man, in the time that it took for this thing to charge and turn on, I almost finished fixing a PS5. Thanks for watching. We'll fix something else in the next video. Maybe we'll do a PS5.